Well, hello, boys and girls. How are you? Are you having a great day today? I am. And we are here to do another science lesson, of course. That's what we always do together. If you can see through the window, you can see some rain. And you might be thinking that we're going to be talking about rain today. And that's the reason that I am purposely in front of the rain. And in a way, we are going to be talking about rain, but not really. Just something that happens when there is rain. It is related to maybe a colors, and it has the shape of an arch. And in many fairy tales, they tell you that there is a pot of gold at the end. Okay, that gave it away. Of course, we are going to be dealing a little bit with the rainbow. But you will see why I just said a little bit, okay? So let's get into our learning target. I can explain what a prism is and what happens to light when it goes through a prism. That is our learning target today. So you heard and you read the word prism, and you also heard the word light and what happens to light when it goes through that prism. And I want to make a connection, of course, between the rainbow and a prism. This is what I want you to do next. I want you to, in your notebooks, write what you know about rainbows. What is a rainbow? When do they happen? What is a rainbow? When do they happen? Something else. And how do you think that they are formed? How are rainbows formed? What is a rainbow? When do they happen? And how do they form? So pause the lesson and write in your notebooks. Now let's share what you wrote. What is a rainbow? When do they happen? And how do they happen? Okay? So let's talk about that. Talk about that with me or with your teacher. If you don't have a teacher, then talk to somebody at your house. If not, just read it to yourself. Okay? Let's share. So of course we know the basics of a rainbow, right? It is usually we see it in the sky. It has many colors. It has the shape of an arch. It usually happens after rain, or when it's raining lightly. And what else? Well, I don't want to talk about how it is formed, because actually that is much of the lesson today, okay? You might be thinking, however, why is Mr. Brisson asking us to describe rainbows and talk about rainbows when there is nothing on the learning target about rainbows? Well, if you saw the word prism and what happens to light when it goes through a prism, then you will understand by the end of the lesson why it is that we are talking about rainbows right now. Let's do a little review about light. So let me ask you a few questions. How does light travel? How does light travel? You remember? It can travel through a vacuum, and we discussed that vacuum was not a vacuum cleaner, so it can travel through a complete empty space, right? It doesn't need any medium to travel. And how does it travel? Do you remember? How does light travel? See light through the window now. Traveling. It travels in waves and in straight lines, right? So we know that part. And Today, we're going to look even deeper at light. So not just what it is and how it travels, but what does it look like inside? Okay, so let's get started. So I want us to look at this word, or two words, electromagnetic radiation. Electromagnetic radiation. I know, long. It sounds like a college word, but let's look at it. And you might be thinking, Mr. Bresson, you're confusing us too much. That word is too long. That is for grown-ups. Well, don't worry. You don't have to remember the word. I just want to mention it to you. And in case that you see it, you will recognize it. So electromagnetic radiation, basically, okay, is all the waves, okay, all the waves that come from the sun, okay, all the waves that come from the sun. And in those waves, in the middle of those waves, okay, are the waves that we can see, which we call light, okay? So electromagnetic radiation is all the waves that leave, all right? We cannot see all of them. We can only see the ones that we call light, all right? So today we are going to specifically concentrate on those light waves, the waves that we can see. We can see light, and so we're going to try to look inside. That sounds mysterious, looking inside light. And for that, we have to talk about prisms. Have you ever heard that word prisms? Maybe in math? Do you hear that word in third grade? Prisms, rectangular prisms, triangular prisms. You hear that word? Well, let's look at what a prism is. So those are prisms, okay? You see them? Those are prisms. And let me show you, those are drawings, okay? And let me show you a real one. Here you go. So we specifically want to look at these ones that are made of like a glass or a transparent material, okay? So now that you know what a prism is, which is part of our learning target, what happens when light, okay, when light goes through a prism, okay? What happens? So remember that we started with rainbows? Well, raindrops can act as a prism, okay? And what happens when light goes through the raindrops? We end up with a rainbow. So what happens when light goes through a prism? It's your time to write down. What happens when light goes through a prism based on what we know about rainbows? Take a couple of minutes and write it down in your notebooks. So what happens when light goes through a prism? We end up, that's right, I'm sure that that's what you wrote down. We end up with a bunch of colors on the other end. But that's just what we can see. Let's see exactly what is happening there. So boys and girls, when light goes through a prism, it slows down, okay? It slows down. And when it slows down, you can see over here in that illustration that it bends a little. So the light waves that were going in a straight line, they bent and they continue on a straight line, but in a different, slightly different direction. You see that? And when they slow down, the light is broken down into different waves. And each one of those colors is a wave. Do you remember from previous lessons what the wavelength is? Wavelength? You remember? Can anybody share with us what is a wavelength? Do you remember now? Remember the top of the wave is called the crest. And then from crest to crest, that is the wavelength. which is sort of the distance from wave to wave, okay? And the reason that I mentioned wavelengths is because when light goes through that prism and it gets broken down, it gets bent and broken down into the different colors, each one of those colors have a different wavelength. That's right. What colors can you see there? Red, orange, yellow, green, blue, indigo, violet. Which one do you think, which color do you think has the longest wavelength? And which one has the shortest? So think about it. Think about it. Let me show you the picture one more time. So which color do you think has the longest wavelength and which one has the shortest wavelength? What do you think? I'll give you a clue. First and last. Well, I'm sure you guess now after that clue. The red has the longest wavelength and the violet has the shortest. And if you remember, when the wavelengths are longer, it's because there is less energy. And when they are shorter, up and down quickly, it's because they have more energy. So the red wavelength or the red wave has less energy and the violet has more. Those are the waves that we can see. On top of the red, there are more waves that we cannot see. The human eye cannot see them. And below the purple, or the violet, excuse me, there are more waves that the human eye cannot see. That's where, remember, we said electromagnetic radiation has all those waves that we can see, but it also has waves on top of the red and on the bottom of the violet that we cannot see, but they are there. And with special equipment, we can see them. This diagram shows those waves perfectly. Okay, so you see the red are longer, and then orange a little bit shorter, yellow a little bit shorter, green a little bit shorter, blue shorter, indigo shorter, violet shorter. And that is the light that we can see, that the human eye can see. And on top of the red, remember we said there are more waves, and on the bottom of the violet there are more waves. But those are the colors that the human eye can see. Those are the light waves that the human eye can see. I can see that those bananas are yellow, and that these tangerines are orange, and that these radishes are red. And do you know that those colors are totally related to light waves? But that is going to be our next lesson. So I'm not gonna jump ahead. Right now, I just want you to, the learning target, okay, let's look at it one more time to make sure that we have really dug in, okay, and are able to answer anybody that asks about our learning target. I can explain what a prism is and what happens to light when it goes through a prism. I think you can do that. Absolutely. So what is a prism? Okay. Let me show you a picture again. Here you go. Here are a few pictures. Okay, those are drawings. And here is a photo of a real prism. All right. So that was our first part of the target. And what happens to light when it goes through a prism? Okay. So now I want you to pause the lesson, and in your notebooks, I want to make sure that you can explain this clearly, okay? In your own words, that you can explain it to anyone that asks you, whether it is a little child or an adult, okay? So now explain in your notebooks what a prism is and what happens to light when it goes through a prism. Okay, so pause the lesson and write in your notebooks. And now you can share with your classmates and with your teacher what you wrote down. Probably 3 or 4 of you can share that and prove to yourselves and to your teacher and to anybody that asks that you know what a prism is and what happens to light when it goes through a prism. All right? So have an awesome day, and I will see you next time. And remember that science is everywhere. Bye-bye.